Session Chair, Mr. Anurag Sinha, Executive Director Technical and Head of Structural Division, Engineers India Limited. Mr. Sinha has over 36 years of professional experience in design and execution of major national and international projects across hydrocarbon, infrastructure, and metallurgical sectors. He has specialized expertise in reinforced concrete and steel structures, including earthquake, wind, and blast-resistant design, and has contributed extensively to repair and retrofitting practices.
As introduced, I am Anurag Sinha, ED Technical, Engineers India Limited. The next topic is by Dr. Ajay Chaurasia, who will be joining us online. And Dr. Chaurasia is currently serving as Chief Scientist and Head of the Structural Engineering and 3D Concrete Printing Group at CSRI, CBRI, Roorkee. He earned his PhD in Structural Engineering from IIT Roorkee, focusing on the performance evaluation of confined masonry buildings under cyclic load conditions. He has authored over 200 technical papers and more than 175 institutional reports and 15 books covering a wide spectrum of structural and construction practices. That is a huge number. He has overseen large-scale field implementations, including over 40,000 confined masonry buildings, seismic retrofitting of over 300 plus critical structures, construction of over 2.5 million housing units using precast monolithic techniques, and major national initiatives like the Lighthouse projects and mass housing for all. He has also led projects for post-earthquake reconstruction in Nepal and disaster resilience initiatives in the Himalayan region. He was instrumental in establishing the Building Dynamics Laboratory, the Construction Technology Demonstration Park, and India's National Earthquake Engineering Test Facility, that is NEETF. Dr. Chaurasia is an active member of BIS and DMA's post-earthquake reconnaissance team and various professional bodies including IACT, ICI and Institute of Engineers India. He has represented India in international R&D engagements across Italy, Taiwan, Portugal, Canada, Myanmar, Turkey, Malaysia, Bangladesh and Nepal. His excellence in R&D and technology innovation has been recognized with multiple awards including the Disaster Risk Reduction Award, IA Structi Engineers Award, Best Engineer Award and Vishwakarma Award. So I welcome Dr. Ajay Chaurasia, who has joined us online to start his this topic and enlighten us on the various aspects of risk assessment and retrofit of towns. Over to Dr. Chaurasia, and the time is 30 minutes.
Yeah. Am I audible?
Yes, sir, you're audible. You need to switch on the mic. Switch on the camera.
Camera is something creating problem anyway. Hello. So I'll start. I have shared my slides. Is it? Is my slides visible, please? Yes, can I have it?
Yes, sir. Go on.
Hello?
Your slide is visible, sir. You can go on.
Thank you. Good morning, respected dignitaries, ladies and gentlemen. First of all, I sincerely apologize that I could not be there in physical mode to discuss on this big issue because of important issue from ministry. So I'm speaking from Bageshwar. Thank you for showing your interest and for this particular presentation. So today's presentation will be from I'll be focusing on risk assessment with the special emphasis on multi-hazard, particularly on Indian Himalayan region, because that is highly vulnerable from different kind of, and there are retrofits and typologies available in HR region. So whenever you talk about in which is around 500 kilometer long, 250 kilometer wide, housing around 13 states. Along with it is having international boundaries to 5 countries, having a land of 5.3 lakh square kilometers, 16% of the land for India, and around 50 million population it is accommodating. In addition to that, it is a very important location strategically point of view, as well as it is feeding 50% of Indian population indirectly from water point of view and climate resolution or point of view. But that means this is a highly important region. At the same time, it is high from whether it is a landslide, earthquake, cloudburst or debris flow. So whenever you talk about the risk, so when it is basically a product of hazard into vulnerability and exposure. So it is very clear that we can only estimate the hazards and we can estimate the exposures also, but vulnerability is a very important aspect which is under the control of architects and engineers, and basically as a whole we need to focus on reduce the loss of life and to the natural environment in after any kind of hazards. So in short, focus is on people and natural environment, and as mentioned that hazard and exposure can be estimated and we have to minimize the vulnerability. That should be on our first priority. So when you are talking of different kind of hazard, so this you might have exposed in recent past, that is in Dharali on August 5. So all of a sudden this kind of a debris flow happened, which has started at so basically Dharali is sitting on an abyss. So when you talk about the Dharali town as such, so this particular town is sitting at a MSL of 2,500 meters and on a very flat land, very gentle slope. And after the town is finished, thereafter it is a steep slope which is around 2,600 meters high. So at the top of 4,600 above the MSL, so that starts that is the basically basics of Srikhand glaciers. So this particular debris flow happened almost at an altitude of 2,100 meters down at an angle of around 70 to 80 degrees, and that's why, and it has created this kind of a HEVOC. And after the HEVOC pictures also you have seen that very important temple there, that is the Kalpa Kedar, which is having a height of 36 feet. Now it is under the debris by feet. That means total 50 feet debris have happened. And whatever the housings were there, hotels, housing and different infrastructure, everything is buried in the debris. So this kind of a disasters happen in this particular vulnerable region or fragile region. So this is the debris flows for Dharali. So this is the before, this is during and after. This kind of you can see and view how a beautiful town has become ruined into the debris. Similar kind of, so this is the Dharali, different townships, around 200 plus houses totally vanished. Before and after, same thing happened after 2.5 hours. Around 8 kilometers away from particular place is similar kind of a situation. You can see before and after. So my intention is that we need to focus on setting of a town or a building for whenever any habitat is taking place in such a vulnerable situation. So this is the another example of Sananchetti, which is around 60 kilometers away from this particular location. So herein you can see the before picture. What happened due to the cloudburst, debris flows came in, and this is the Yamuna river, and that has, because of that debris a temporary dam kind of artificial lake has been created on upstream side of the debris, so of the Yamuna. As a result, entire Sianchetti was beneath the around 2-story buildings were totally drowned under water, inundated under water. You can see the picture after this. So not only earthquake, but this landslide, cloudburst, flooding, excessive rainfall, these are the different scenarios. And on another hazard, which is subsidence of ground, which we have witnessed in January 2023 in a city, in a town called Joshimath in Chamoli district. So this was basically a national crisis, and wherein CBRI has immediately jumped into to provide the safety and technical guidance for the people for such national crisis. Immediately after that, all the 2,400 houses have been instrumented, monitored, and progressive cracks were noted every day, and vulnerable buildings were identified in terms of usable, unusable, and demolished. So this classifications has been carried out based on the typology, based on the vulnerability parameters, based on the crack width measurements and an increase in the crack width, and the crack classification was carried out in relation with the national and international standards, particularly the MSK intensity. A very quick land vulnerability map was plotted for different administrative zones, classifying the different houses in different classes. Now, subsequently, again, the risk map was plotted. Integrated approach was adopted by integrating the data from different institutions along with the basic data captured by CBRI, and the landslide macrozonation map was plotted for in terms of for the mitigations and future development point of view. So this is how the multidisciplinary, multi-institutional approach has to be adopted for dealing with such kind of a national scenario or national crisis. Now let us move from landslide or cloudburst and other disasters to seismic activities. So now in our country, we are coming with the new Indian standards on IS 1893, that is seismic zoning map. So this, according to which the seismic zone 2 to 6 has been classified. Again, this particular region is classified under seismic zone 5 and 6, having a PGA more than 0.32 to 0.5 plus, basically based on the 2475 years return period and importance of the structure. So for the ordinary structures, it is more than 5G, and for other important structures, it has been classified differently with different return period. So having said this and keeping in mind, we have witnessed in the past these different kind of effect building and its behavior of the buildings in different earthquakes, which is basically from ground shaking, masonry buildings, not only in India but in different part of the world, how they have failed and what were the deficiencies in those buildings. So these are buildings, precast buildings, fabricated buildings in abroad, in India as well, and the other infrastructure like bridge, tunnel, different lifeline, communication towers, roads, even dams, then communication, power substation, then in this non-structural element also behave miserably. We have witnessed the Northridge earthquake. In excessive use of facade is also risky because it is causing a falling hazard, including the content. So having known the different kind of damages which earthquake is creating for the buildings infrastructure, and in the past its performance, now let us take a lesson from Taiwan, wherein around 7.2 and 7.3 magnitude earthquake happened in 1999 and 2024. How did Taiwan transform? That can be witnessed on the basis of losses in terms of lives and properties and business. You can see that shift of loss of life from 2,400 in 99 so to 18, 11,000 injured, 1,000 injured in the number of buildings, 1 lakh buildings were destruction, now only 84. So this is a very constructive approach that is basically for extensive mitigation strategies by adopting massive scale retrofitting of the region. And definitely, yes, the stringent norms in implementations for the new constructions. So this particular Taiwan has addressed in verticals, new existing constructions. Now, this particular approach has been kept in mind, and we have worked on the risk assessment of not only one particular building, but for the entire town. So for that purpose, we have taken in the study 6 towns, that is, those are 3 in Uttarakhand and 3 in Himalayan. And they have been investigated thoroughly in terms of their hazard, vulnerability, exposure, risk. And risk not only has been simply studied, but it has been quantified at different level of shaking, that is 0.3 G to 0.7 G, and in direct and indirect losses it will create. But that has been again transformed in terms of a risk map that will be basically a very important tool for the administrator or bureaucrats for implementation consideration. So when you talk about the Himalayan region, we understand that it is having high seismicity, vulnerability of buildings, infrastructure is in danger, and we need to rethink on this. And when you talk in terms of hazard, complex lithology, lineament faults, geomorphology, and complex natural setup should be given proper attention, understood properly, and then only we should think of any retrofitting and mitigation strategies. When you talk about hazard, we know that the seismic tectonic map of India having lot of numerous faults, MCT, MBT at different regions, that has to be considered when we are conducting such kind of study. At the same time, past earthquakes has to be studied in detail for the study area, and over and above that has also we have to keep in mind the revised updated seismic zoning map of India that is given in IS 1893 2022-25 draft. So these documents, we have considered factors in terms of geology, thrust fault information, geotechnical properties, and susceptibility assessment. In this particular study, we have not only given simply earthquake as a prime attention, but liquefaction and other hazards also are under consideration. When you are talking about the vulnerability, so we know that around 85% buildings are non-engineered, unreinforced masonry buildings, and even our critical buildings like schools, hospitals, important buildings are also at present housed in unreinforced masonry buildings. And it is known that the unreinforced masonry buildings are vulnerable in case particularly earthquakes, and there will be a collapse possibility if no retrofitting measures or seismic resisting measures have been adopted. So in short, our habitat is in questionable, at risk. We need to think over it, and for that purpose, we have how to evaluate vulnerability to address this issue. We have adopted 2 approaches. First of all, the prescriptive approach, and another the analytical approach. So in the prescriptive approach, we adopted the different weightage assigned or penalty in terms of penalties assigned by one IS 18935. So before that, we have done extensive survey of all the buildings door to door in all these 6 towns and identified which are the different typologies which are available. Over and above, for the prescriptive approach, we have adopted the penalties which have been given different parameters in terms of setting, soil, foundation, then architectural features, thereafter structural and other material and other consideration. And based on that, these penalties have been verified and modified also as per the Indian context, construction features, and the sum of the entire penalty has been then done some statistical analysis and thereby calculated the earthquake feature index. This earthquake feature index basically further help us in classifying the damage grade. That has been again validated from the past damage history. Over the last 50 years, earthquake happened in Indian context. So Indian typology, which has not been studied in depth properly, that has been carried out in this particular approach of prescriptive approach. At the same time, we have also carried out the fragility curve development for the different Indian typologies, wherein 11 earthquake records of different geology similar to the IHR region has been taken from PEER, that is the Pacific Earthquake Engineering records, and then those time histories were scaled up between the range of 0.05 to 0.7 G, and all the non-linear dynamic analysis has been carried out, and based on that, the fragility curve were developed for different typologies. So particular typologies available in this particular region was masonry buildings and some traditional buildings and RC, particularly the unreinforced RC structures, non-engineered buildings, undetailed. And based on that, the fragility curve basically provides me the possibility of and which transforms my shaking to success. So this is the approach, and approach been limited of it, but also from flood and slight consideration as well. When in terms of exposure, basically exposure to your infrastructure and population, assets and population. This particular so we had set information of number of houses and how many population is sitting on that. But in general, we can take at this point of time the census 2011 and enhance it by around 16 to 20% based on the statistical growth, and we can take out it further. Now, based on this particular method, we calculated the risk in terms of number of fatalities, injuries, homeless, and the direct and indirect economic losses. And in addition to that, usable buildings also. And for that purpose, again, we developed the damage probability matrix in terms of loss to people, loss of the people in terms of dead and injured. Similar to the usable and unusable buildings. And for that purpose, for economic loss calculations, we considered the construction rate, which is prevalent in the region, and that for different kinds of typologies, and has been adopted in this particular study by development consequence model. And definitely, whatever the damage probability and other data which has been taken very carefully based on the present prevalent rates and the damages based on the past earthquake data in Indian typological context. So now I would like to present here quick overview of a case study on one of the town that is on the Kandahat, which is in Himachal Pradesh. So in this particular, you can see this particular town, which is spread over 26.13 square kilometers, comprising 2 panchayats, 26 villages, and 22 having the population and demographic details you can see here. So it is a very scattered town, and habitat is also very much scattered. So it was very tough time for the team to carry out the survey. But nevertheless, we can also consulted the past records and calculated the earthquake scenario and extreme rainfall scenario, and which is triggering the landslide. So that was basically assumption or consideration for that was to the rainfall has whenever rainfall exists and it exceeds the 50% of ground saturations, it will trigger landslide. Based on this, the different hazard level were calculated by considering the factor of safety at different scale from low to very high. In the similar way, the earthquake hazards have been calculated from low to very high based on the subsidence vertical under Z directions. And again, based on this, the data was correlated, which is more or less similar in both the approaches. Again, based on the survey, the outcome is presented here. The different buildings with different level of risk in terms of high, moderate, and low for based on the prescriptive and detailed analytical approaches. In summary, the consequences has been noted at different PGA levels for the parameters of fatalities, injuries, casualties, economic losses, and unusable and usable buildings. And the results were plotted in terms of earthquake scenario based fatalities estimation ranging from 0.3 G to 0.6 or 0.7 G, classifying in the different sections, that is high, moderate, low. So this is for casualty, losses. Then this is in summary at a glance characterization has been done, which will be a very important tool for the bureaucracy to for implementation, wherein we have also given a focus that we should establish a resilience center at critical locations based on the losses and should be approachable in post-disaster. Now, our mission was to reduce the risk, whatever the risk is there. So by 2047, we should have zero tolerance, zero loss of life and property. Nowadays, we are taking 5 years as a recovery period. We need to reduce it by 5 months. So definitely to meet the vision, we should have a vision, robust vision in different sectors. But compliance for the new scientific if really so our strong recommendation is that we have in general 2 to 3 story buildings in such region in the country, mostly unreinforced. Now, whatever the construction will happen, now no more unreinforced masonry building, only use confined masonry buildings, which will give a resilient buildings in years to come. Because it makes use of locally available construction materials and scales, and economically it is hardly 5% more than that of unreinforced masonry. And we have evaluated experimentally also, the numerically also analytically, and this kind of a system should be provided in such vulnerable region. Now, on the second vertical, what we should do on the existing building, which are highly vulnerable, and mostly or 90% buildings are masonry buildings. For that purpose, we have evolved a quick, cost-effective, scalable retrofitting technique, that is steel thin lintel band, that makes use of MS flat sections, which has to be provided at different locations. So, for example, we have n number of cases of buildings in our country which are unreinforced, highly vulnerable, and we have to take a call after visual inspection. For the low seismic zones, that is seismic zone 2 to 3, we can provide only MS flat at the lintel level on both all the walls, connecting all the walls together. That is creating an integral oxide action. Over and above, for the high seismic zone, such kind of a flat with the angle sections can be provided at all the walls at different levels, as you can see here, for the high seismic or moderate to high seismic zones, that is seismic zone 4, 5, and 6. Now, what is the method? So for this purpose, we have conducted the full-scale experimental investigations in CBRI and evaluated the performance of unreinforced masonry building after it was damaged using this kind of a technique. In addition to that, the numerically also it was extrapolated for 1, 2, 3, and created matrix which clearly states that under set seismic zones, and if you have a different number of stories, what should be the retrofitting measures to be adopted in terms of flats at lintel level, sill level, and vertical angles. And according to the site conditions, you have to location of the building, you have to pick one of them and implement. So this engineer can go ahead straight away by using this, because this has been validated also and critically evaluated. And when you talk about the cost, which is reasonably very reasonable, that is around 3 to 5% of the new construction. And important thing is that by implementation, it takes minimum possible time to 3 to 5 days on the material ready. Cost is also less, and one important thing is that the occupant need not have to vacate the house. So that is very important. So such kind of interventions or retrofitting measures need to more awareness and take to the masses for mass retrofitting approaches. So in conclusion, I would like to summarize that we understand that the vulnerability of the our country, there is need to take bold step for constructing only confined masonry building for low to medium rise construction, and for the existing one, we need to undertake the massive retrofitting program, the stable approach. In addition to that, in addition to this kind of approach, we have to first of all focus that whenever we are sitting should not be given isolation. We should give a holistic look. Sitting, whenever any town is developing or the habitat is developing, it should be hazard-free region. It should not be we should not witness another case like Dharali, which is smart village, first smart village of the country. So this holistic approach is required. And with this, I would like to, I'm grateful to organizers of Felicitation, and my special thanks to Mr. Jayant, Mr. Pulkit Kukreja and Shaunak, and Government of India, and all of you for your kind attention and patience hearing. Before I conclude, I would like to invite you to the CBRI for the forthcoming 4th International Symposium on One Health and One World, which is happening in 2025. So around 75 international participants and dignitaries will be there, and they will be focusing on different aspects world over. In addition to that, around 200 engineers and academia and scientific community is also participating. So this is the huge event. I request all of you to please join in this particular symposium and enrich our society for years to face to make it totally resilient. So thank you so much for your kind attention and patience hearing. Jai Hind.
Thank you, Dr. Chaurasia, for your enlightening topic, for covering the details about the retrofitting of various towns in the Himalayan region, and also talking about the new technologies developed for confined masonry buildings like the steel twin lintel band, which you have codenamed as staple. Thank you very much. Unfortunately, due to some network issues, we won't be able to take the questions right now, and I request audience questions, if any are there, just write it down and give it to the organizers, which can be communicated to the speaker, and you will get the responses. Thank you.
Thank you, Dr. Ajay Chaurasia, for highly informative talk, and our sincere thanks to Mr. Anurag Sinha for chairing the session. I would like to request Mr. Jayant Kumar to kindly felicitate Mr. Anurag Sinha. With that, we'll take a short tea break. But since we are running a little behind time and our next speaker, Dr. Marioni, has to leave by 12:45, I request you all to reassemble back here in 10 minutes. And please join outside for a hall for refreshments. Thank you. Welcome back, everyone. For our third technical session, I would like to welcome Dr. Abhay Gupta, Director, Skeleton Consultants Private Limited, as session chair. Dr. Gupta is a distinguished structural engineer with wide-ranging experience in steel and RCC design, retrofitting, rehabilitation, and special structures. He's also known for landmark projects like 351 feet Lord Shiva statue at Natwara and India's tallest bungee jumping tower at Rishikesh. He has received multiple national honors, including Eminent Engineer Award and M. Visvesvaraya Award. He has represented India at several international forums across the UK, Europe, and Asia. Thank you, sir.
Thank you very much, Devani.
Okay.
And
Okay, I can start.
it's wonderful to have Dr. Agostino Marioni,
Agostino, just 1
who
minute.
would be online joining us on this very special subject. We are listening about the earthquake resilient structures since morning, alternative technologies, and then wonderful philosophical presentation from Dr. Pradeep Kumar about RVS. But Dr. Marioni is going to speak about the base isolation used in the hospitals particularly. To give you a brief introduction about him, he graduated from Milan Polytechnic in 1966 with a specialization in bridge design, founded ALGA in 69 and has been chairman until 2012. He has been chairman of the European Commission for the Standardization of Structural Bearings, author of EN 1337, and member of the European Commission for the Standardization of Anti-Seismic Devices, author of EN 15129. He is currently chairman of the Hirun International and Seco Hirun Private Limited, very highly specialized companies in the field of structural devices with offices in Taiwan and Delhi and branches in China and Italy. We have Mr. Ujjwal also from the same company, and we have Mr. Mohit Kapoor as well, connected with Seco Hirun. He is author of over 100 papers presented on various international conferences and authored 2 books also. One of them is something in Italian, and other one is anti-seismic devices. So with all these great credentials, I welcome Mohit and Ujjwal on platform with me, and I invite Dr. Marioni to please take up the presentation. Dr. Marioni has to leave for some assignment, so I request that please take up the things quickly. Thank you.
Okay, thank you. Thank you very much for your kind introduction. And now I start immediately. And sorry also for the delay in connecting. So can we see next slide? I will speak about the seismic isolation of hospitals, but first of all, few words about the seismic action and the base isolators. These concepts maybe are familiar with all of you, but I make a short review. So the seismic action normally we define through the acceleration response spectrum, and the response spectrum is given by the Indian standard as well, and is the function of the grade of seismicity of the area, the soil property, the damping capacity of the structure, and the return period. Next one. Next slide, please. Next slide. So here is the acceleration spectra given by the Indian standard, and there are 3 graphs given in function of the soil type, and these are given in coefficients that have to be multiplied by the seismic intensity. See the next one. The next slide. So here are given the zone factor Z. As you know, there are 5 seismic zones in India, and 59% of the Indian territory is subject to earthquake. So a great part, and so the seismic action must be considered in almost all cases. So see the next one. Next slide, please. Next, please. So all the response spectrum are similar in all the world. Here are the spectrum given by the European standard, and there are many graphs given in function of the damping of the structure. And having a look to the spectrum, we immediately understand what we shall do to reduce the seismic action in a structure. To reduce the acceleration, we have two strategies: increasing the period and increasing the damping. So next one, please. Next. And here are the most common anti-seismic devices. The first two are the base isolators, and they can be in rubber or sliding pendulum. I will explain later in detail. This base isolator, the base isolator apply the two strategies. So they shift the period and they increase the damping. The other anti-seismic device, the most common, are hydraulic devices, dampers and dynamic links. They apply only one strategy. They can dissipate energy, especially the viscous damper, or they can create supplementary links in the structure. Next one. So what we intend when we say base isolator. Base isolator, as defined in the European standard, that is, I believe, the one of the most of the better of the world. Base isolator are devices that fulfill four functions. They support the weight of the structure. They provide lateral displacement capability, they provide recentering capability, and they dissipate energy. And so they apply the two strategies for the reduction of the seismic action. Next, please. So the isolators are placed between the structure and the foundations, and they force the structure to swing according to their own natural period. And they dissipate energy by one of the following principles: viscosity of rubber in the high damping rubber bearings, yield of metal in the lead rubber bearings, or friction in the sliding pendulum. When we apply the base isolation, we introduce a relative displacement between the structure and the foundation. So to apply the base isolation, we must verify that this displacement is possible. Next, please. Okay, the base isolator can be schematized in a very simple way. They are harmonic oscillator. The rubber base isolator can be modeled as a spring with a mass, and they shift the period according to the formula, so proportion square root of the mass divided stiffness multiplied to P. Instead, the sliding pendulum has a different scheme and can shift the period according to the square root of the length of the pendulum or the radius divided the acceleration constant g. We will see the implication of these two rules later, comparing the performance of the two systems. Next, please. Next. So here, in summary, the high damping rubber bearing acts like a spring due to the rubber elasticity and dissipate energy by the viscosity of the rubber. However, the damping that can be reached with this device are not very high, limited to 15–20% of damping. Next, the lead rubber bearing, the same spring effect is given by the rubber, and the energy dissipation is given by the yield of the lead core. So they can dissipate much more energy with damping up to 30% or more. Next one are the sliding pendulum. They support the weight of the structure, they provide lateral flexibility, they provide recentering through the potential energy storage. So when they are moved from the center, they store energy, that is given back, recentering the device. And they dissipate energy by the friction of the sliding material. We will see that these devices are the most efficient base isolators. Next one. Next. So there are, I don't enter too much in detail, but there are three types basically of sliding pendulum, with one or two sliding surfaces and with center articulation. Okay, but this is details that you will see maybe in the catalogs of the manufacturer. Next, please. Next, okay. So the design procedure for a base isolated structure, we have three possibilities. We have static linear analysis, or dynamic linear analysis, if the structure and the anti-seismic devices can be modeled as linear. We will see that even with non-linear base isolator, we can apply an iteration procedure, and so to make the linear analysis. Or the time history analysis is the most complex and most reliable analysis. However, for the hospitals that are construction not too high, I always recommend to make the simplified analysis. Now I don't have time to enter in this simplified analysis, but you can find the criteria of this simplified analysis, for instance, in my book, Anti-Seismic Devices. Next, please. Next. Okay, this is okay. So the simplified analysis for high damping rubber bearing, they are defined by two parameters, but we can perform the linear analysis and take into account the viscous damping by a formula that is given, or by some parameters that are given also in the Indian standard. For the lead rubber bearings and pendulum, they are not linear. They are also defined by two parameters. They are not linear, but we can do the linear iteration analysis step by step. So, introducing in the analysis a tentative displacement and introducing in the second step the output of the first analysis, and so on. In any way, you can find a clear explanation of this in my book, for instance, or in the literature. And okay, this is not the main topic of our presentation. Next, please. Next. So about the hospitals now. Of course, we would like every structure to be resistant to the earthquake, but if you look how many buildings there are not only in India, in all the world. You cannot pretend to protect every building. But the hospitals are indeed the most important. In all the nation, hospitals are the priority number one. Why? Because after an earthquake, of course, you need the hospital, and they must be functioning. They must not be damaged from an earthquake. This is very important. Next, please. So, how many hospitals shall have a nation? I made a short, I verified this in an Italian economic atlas that gives all the information for all the nations. And here you see that there are nations having 3.9, 5.5, 7. We exclude Japan, they have too many hospitals. But I believe that a target value for a nation that pretend to be industrialized should be around 3 beds each 1,000 inhabitants. Next, please. Next. So what about India? I checked the data of India, and I found that the available beds in India are around 0.5 each 1,000 inhabitants. So clearly not sufficient. To reach the target of the 3 beds for 1,000 inhabitants would require to make a lot of hospitals, and 59% of that should be seismic isolated. So the erection of such a huge number of hospitals for sure will require several decades. So it's expected that in India will be built a lot of hospitals, and now I will show why the only way to protect the hospital is the base isolation. Next, please. Next slide. So, if we consider the structure of the hospital, normally hospitals are not very high buildings. So, around 10 floors is normally the maximum height. This implies a very short natural period of the order of 0.5. If you look at the response spectrum, this short period implies a very high amplification of the peak ground acceleration, so 2.5 times. So in the most severe area, seismic area, this means we reach up to nearly 1 G acceleration in the hospital. With 1 G acceleration, everything inside, even if you do the building very strong, everything inside will be destroyed. And so the function of the hospital will be completely destroyed, because hospital contains very high-tech diagnostic devices, monitoring and surgery equipment. They are very delicate, and a maximum acceleration of 0.1 G is recommended to have no damage in the equipment. So this should be the target, 0.1 G. For your understanding, what is 0.1 G? Imagine one car that is accelerating from 0 to 100 kilometers per second in 27 seconds. So this is a very smooth acceleration, and this is the smooth acceleration that can be supported without any damage by the equipment in the hospital. So this is the target. So see next please. Next. If we look at This is the spectrum of India for zone 4 medium soil. So if we have the non-isolated building with 0.5 seconds natural period, you see that is the dot in the top of the diagram. If you apply energy dissipation only, we can reduce the acceleration, but not more than approximately 50% to 0.4 G. This is not sufficient to protect the equipment. To protect the equipment, we have to apply the base isolation to reach the acceleration target that is commonly adopted for hospitals. So next, please. Next. Now, the base isolator, as we can see, can be normally in rubber or in pendulum, but I strongly recommend to use pendulum because the performance of the pendulum is much better. Why? So first of all, the period T in the rubber isolator is a function of the mass and the stiffness, but the mass in the hospital can vary. They add some equipment. The stiffness can vary according to the temperature and to the agent. Instead, with a pendulum, the period cannot vary because it depends on the radius and on the gravity constant. Another important aspect is the stiffness of the rubber devices is an intrinsic value, and so to design an hospital, you have to evaluate the center of stiffness of the devices and try to make it coincident with the center of the mass. But the mass can vary, they can shift some equipment, so this is not so easy. Instead, as we see, the stiffness of the pendulum is proportional to the mass, and so theoretically there is no the center of stiffness is always coincident with the center of mass. Can we see the next slide? Next. So what happens if the two centers are not coincident? The structure will rotate in case of earthquake, and in fact, when computing